from this given information, I'm asked to come up with a parametric equation, or sorry, a pair of parametric equations. X is a function of theta and y is a function of theta. I'm told it's an ellipse, so immediately I know I'm going to be using sine squared theta plus cosine squared theta equals 1. I think it's important to sketch this first. You're given foci at, I can just draw a rough sketch, at 7, 2 and 13, 2, and vertices at 5, 2 and 15, 2. Now, you can take, obviously, where our y's are all 2, it's all going to be in this horizontal line, and we can quickly ascertain that we're going to have a horizontal orientation. Now, if I'm looking at these foci, if I take the midpoint of 7 and 13, in other words, 7 plus 13 is 20, divided by 2 is 10, I can tell you very quickly that HK is going to be 10, 2. Well, if 10, 2 is HK, then center to focus, I'm going from 10 to 13 is 3. So that means C is 3. And center to vertex is A. And the vertex is at 15, so 10 to 15 is 5. A is 5. I know that A for an ellipse is the biggest, so B squared plus C squared equals A squared becomes 3 squared plus C squared equals 5 squared. 25 minus 9 is 16. Square root of 16 is 4, or just think of that as a 3, 4, 5. So I know, I'm sorry, I was solving for B. My bad. So switches. I know A and C. I know C is 3, and I didn't know B. And so now I've got B is 4. So I'm going to go up and down 4. And I could draw this ellipse here. It's going to look something like that, where my minor axis is 8 and my major axis is 10. That's 2B and 2A, respectively. Well, I know that if I'm talking about a circle or an ellipse, if you watch the last video, you'll know that it's going to be sine and cosine, all right? So I have an idea that in rectangular form, because this is horizontal orientation, I'm going to be x minus h is 10 over a, which is 5 squared, plus, then that's going to be squared on top, plus y minus 2 squared over, my b was 4 squared equals 1. Now, I've got to work backwards. That's my rectangular equation. They're asking now to work backwards. Find the parametric equation. So I know that x is equal to, I usually put x with cosine just because of our long history with trigonometry, x being cosine. I know I have to work backwards. Well, if I want a 5 to be on the bottom, I'm going to say 5 cosine. And if I want it to be minus 10, I'll add 10 there. And y, if I want a 4 to be on the bottom, I'm going to do 4 sine of, if I have a minus 2 there, I'll add 2 there. And if I do that, if I do that and I resubstitute into I'm sorry, I forgot my thetas, right? If I then resubstitute and I work the problem forward and I say this implies that x is equal to, that cosine theta is equal to x minus 10 over 5, and this implies that sine theta is equal to y minus 2 over 4. If I substitute that into that equation, I will get this. So I know I've done it right, and I can be quite confident that I've come up with the parametric equations for these particular conditions. Let's take another look at finding equations that are parametric in nature, given information like this. I'm looking for the parametric equations of a hyperbola with these foci and these vertices. Of course, we want to draw a sketch of it, and we want to keep in mind our Pythagorean triples. Sorry, not Pythagorean triples, our Pythagorean identities. Now, I know that cosine and sine, because of the nature of the plus between them, works very well for circles and ellipses. So either one of these is going to work well for a hyperbola, because when I bring the tangent squared over, I'll get a minus. And when I bring the cotangent squared over, I'll get a minus as well. So if I have foci at 1, -1, and 1, 9, and vertices at 1, 0, and 1, 8, if I take the average of 0 and 8, I get 1, 4 being our HK. And it's a hyperbola, so I know I'm going to go over B and over B and over B and over B, and I'm going to make my box there, and then through the corners of the box I can draw my asymptotes, and so this has got to be a hyperbola with an orientation that is vertical in nature, which means I'm looking for y minus k squared over a squared minus x minus h squared over b squared equals 1. Order matters, of course order matters, and a is always, always, always first. This distance is a. Well, if our vertices are at 1, 8 and 0, 8, this distance here has got to be 4. And the distance, so that means A is 4, and C is, if I'm counting blocks, that's 5. When I use the idea that A squared plus B squared equals C squared, I can see that I have a 3, 4, 5 right triangle, which I'll save you some work. That means B is going to be 3. So I've already got this done. I know it's y minus 4 squared over, my A was 4 squared, or 16, minus x minus, my k was 1, or my h was 1, sorry, over, and my b was 3 squared equals 1. That's what I'm heading for. Well, because my orientation is vertical, I'm going to choose secant associated with the y. Why did I do that? Because I know I'm going to bring this one over and subtract it. Whatever I choose as tangent is going to be subtracted from secant. Because the orientation is vertical, I'm going to choose secant being the y. So if that's what I want, then I'm going to say y is equal to, remember, whatever's in the denominator becomes the coefficient. 4 secant theta, if it was a minus 4, it must have been a plus 4 over here. So this must be, by default, the tangent. If x is going to give us our tangent function, this becomes the coefficient. 3 tangent of x. With a minus 1, I want plus 1 over here. Let's see. If, in fact, these are correct, then I should get this if I work that problem sort of in the forward direction. Well, I know that this would imply that secant of theta is subtract the 4, divide by 4, y minus 4 over 4. And this would imply that x minus 1 over 3 is equal to tangent of x. When I substitute this into tangent squared theta plus 1 equals secant squared theta, I'll get x minus 1 squared over 3 squared plus 1 is equal to y minus 4 over 4. The whole thing, well, I'll square the numerator and the denominator to save us a little time. And if I then subtract this from both sides, I'll get 1 is equal to y minus 4 squared over 16 minus x minus 1 squared over 9 is equal to 1, which is what I want. So I can tell you that I know I'm right.